Hello students, welcome to eduranger.com. I'm here to discuss about a basic concept about mean, median and mode. First of all, remember that for the data in hand, we always need to represent or analyze our tabulated data to understand the nature and the features of the data and what information you want to extract from the data. So the first step to analyze any data in hand is to check the central tendency of the data. Basically, central tendency, it shows the tendency of some central value around which your whole data tends to cluster or move. So basically we have three measures of data: mean, median and mode. These are the basically three measures of central tendency of data which represents a single value, and it is considered as the most representative value of given data set. So that means only a single value represents your whole data, that is mean, median and mode. So before moving to the definitions and explanations, just look at this picture and remember that mean is just an average, or in other words you can say it is an arithmetic mean of observations, that is average of data set. Median is just a middle number of all set of the observations, and mode is the most common observation, that is the most frequently occurring observation. So let's start about mean. So basically, talking about mean, in a layman language, mean is known as average, or you can also call it as arithmetic mean. So mean, average and arithmetic mean, they are all synonyms to each other. It is the most important and widely used measure to represent your data set. So talking about its calculation, mean can be calculated by adding all the observations of datasets and dividing it by total number of observations. Uh, Let us suppose we have dataset 2, 4, 6, 5, 8. So we are given a dataset with the values 2, 4, 6, 5, 8. How we will calculate the mean? We will just add up these values, 2 plus 4 plus 6, and divide it by total number of observations, that is 2 plus that is 5, 1 2 3 4 5. So this comes out to be 25 by 5. So mean value is 5. So this is the case of ungrouped data, that is simple data. So if you have the values x1, x2, x3, xn, n number of values you have, and the mean in arithmetic can be calculated as x1 plus x2 plus x3 up to xn divided by n, that is total number of observation, and it is denoted by x bar. So the data is ungrouped, but sometimes you are given a grouped data, that is classified data, or you can call it as a class data. Then the calculations would be different. In that case, firstly, you need to calculate the midpoint of each class. Firstly, you need to calculate midpoint of each class. Now, point is why we are taking the midpoint of each class. See, we assume in the case of grouped data that the data is uniformly distributed over the range of each class interval. We don't know the exact frequency with which the particular observation is occurring, so we consider that the data is uniformly distributed. In that case, we'll use this formula, that is mean x bar is equals to summation of fx. F is a frequency over here, frequency of each class with which the value is occurring. X is the midpoint of each class, and n is the total frequency. So assume, let's look at this example. In this example, you can see there are 1000 companies. The profit earned by 1000 companies during the year 2019-20 are given, and you have to calculate the average profit for the companies. So in this case, there are 1000 total companies. Look at this, the total of these companies is 1000. So if there are 1000 companies and they are earning different profits, like 200 companies, they are earning profit ranging from 200 to 400, and 100 companies, they are earning profits ranging from 400 to 600, and similarly these. So in this case, you need to calculate the average. How will calculate the average in this case? First of all, you'll calculate the midpoint of all the ranges. So this midpoint of this range is 300, 400 to 600. The midpoint is 500, 700, 900, 1100. So we had already had the frequencies, 200 companies, 100, 260, 220, 220. So total number of the companies were 1000. So you just need to multiply these values, that is 200 into 300, 500 into 100, 700 into 260, 900 into 220, 1100 into 220. So the values of frequency into midpoints are given here, and you just have to add up here. So mean can be calculated like using the formula, this formula. So this is the value of summation of frequency into midpoint divided by total number of companies we have. So the midpoint came up as 732 lakhs. So this is how you will calculate the mean for the grouped data. Okay, so this is all about our mean. So the calculations for ungrouped data is simple, but in case of group data, always remember you need to calculate the midpoint firstly, and then you just need to multiply it with the number of companies and use this formula. Now, if you talk about the limitation of mean, always remember that mean is unduly affected by the presence of extreme values. So, if the data is extremely asymmetrically distributed, then the mean is not a good measure of central tendency. Okay, so let's move to median now. So, talking about median, median is just a middle number. Remember that it is a middle number of the ordered sequence of data. Like suppose you have 2, 4, 3, 5, 6. You have this data. In this data, what you will do? Firstly, you will arrange the complete data in either ascending or descending order. So let's arrange it in an ascending order. So the middle number is this. So this is the median. So what, in other words, you can say that median is just a middle number of the ordered sequence of data. That is, half of the values in data set are lower than the median value, and half of the values, they are greater than that value. That is the median value. So we can also say that it is a positional average. Also, if the number of values, you see, if the number of observations are odd, for instance, we have 5 observations like this, then the median will be third value of the ordered data. In another case, if you have even number of values, suppose this is the even number of values, in that case, what you will do? Arrange the order in an ascending order, 5, 6, and then 8. In this case, you'll see the third value and the fourth value. They are at the position of median. They are the middle values. So this will be the median. So in the case of even number of observations, median will be half the sum of both the values. It is half of sum of third and fourth value. Okay, so therefore, to calculate the median, you need to arrange the data in either in ascending order or descending order, and then find the middle value of data set. So again, this was the case of ungrouped data. When you need to calculate the median for the grouped data, so in case of grouped data, you just need to calculate the cumulative frequencies first of all. For example, what is cumulative frequency? What is cumulative frequency? 120. In next case, you will add up these and the value come out to be 245. These are the cumulative frequencies. Then you'll add up these and you'll get 525, 785 and 940. So this is total is 940. That is, this is the value of n. So you just need to calculate the cumulative frequencies first of all, and then find the median class by dividing the total frequency by 2. So n divided by 2 here is 940 by 2, that is 470th observation. 470. Now where this 470th observation lies? See, 470th observation. Number of employees in first case is 120. Here it is 245. So from 245 to 525 observations are lying here. So here is 470th observation that is lying. So basically this is the median class. This is our median class. Look at the example. So median class is, this is the median class where 470th observation is lying. This is the median class where 470th observation is lying. And 226, 30 is the median class. So once you get the median class, then you just simply apply this formula where this is median is L plus n by 2 PCF, where n is the total number of observations, L is the lower value of median class. Lower value of median class, this is the median class we have selected. So lower value is this, 26. So 26, n is here 940, 940, that is total number of employees. What is PCF? PCF is preceding or previous cumulative frequency. That is, if this is our median class value, so this is the preceding one, that is 245. And this is the frequency. This is the frequency of that median class. So this is the frequency of the our median class. I is the interval of the median class. Interval means this 30 minus 26. This is 4. So this is the interval. So this is how we will calculate the median for the grouped data. Hope you'll understand. So before moving to mode, let's talk about the merits of median over the mean. So median is obviously superior to mean because it is not influenced by extreme values. In fact, if there are extreme values in the data, then it is more satisfactory measure for central tendency. But since it is the positional average, its value is not determined by each and every observation. So you cannot determine the combined median for 2 or more groups. Also, it is less reliable because it is more affected by sampling fluctuations, and it tends to be unstable if the number of observations is small. So now we can move to mode. So mode is basically that value which is occurring a maximum number of times in a given set of data. That is the number having maximum frequency. For instance, you can see this data 8546555. So you can see that 5 is occurring maximum number of times. So the mode of this particular data is 5. So you can say that mode represents majority of the population. Plus, graphically you can see in this graph, this particular observation is occurring maximum number of times. So this is our mode. That is maximum frequency. Now talking about mode for grouped data. In case of grouped data, first of all, find the class interval with maximum frequency. This is simple. You just see the maximum frequency is 20. So this is your modal class. This is your modal class. This is the lower value. This is the higher value. And then modal, after looking for modal class, simply apply this formula. This L is the lower value of the modal class, and this D1 is equals to frequency of modal class minus frequency of previous class. Previous class means this class. And D2 is equals to frequency of modal class minus frequency of post modal class, that is this class 66, 68. So how we will calculate it? So mode is equals to L is 64 plus D1 is frequency of modal class, that is 20, minus previous class, it's 12, that is 8, and what is D2? It is frequency of modal class, that is 20, minus post modal class, it's 10. So it's here is 10. So 64 plus 8 by 8 plus 10 into your interval. Interval is 66 minus 64, that is 2. So the calculation gave this result, 64.88. So this is the mode value for the grouped data. Again, the merit of mode is that it is not affected by extreme values, and if the data is a unimodal, then the calculation is fine. But in case the data is bimodal, then the value of mode cannot be calculated always. So this is the limitation of mode. Also, always remember that the distribution in which values of mean, median and mode, they coincide, then the data is symmetrical. But if the distribution where these values are different, then the data is asymmetrical or skewed. In that case, always remember the value of mean. This relationship exists, mean minus median is equals to 1 by 3, 1/3 of mean minus mode. So always remember that there is a relationship exists between mean, median and mode, and we can calculate using this formula. Thank you for watching this video. Hope you understand the basic concept of mean, median and mode. To read more, visit our blog www.eduranger.com, and you can mail me at jazz831@gmail.com. Thank you.